We want some better integrations with grades and things like My Courses. Additionally, user accounts are missing some functionality. We can't actually reset passwords, which is something that we ran into. And looking back on that, it might have been something nice to have earlier on. And additionally, we've built a really strong, powerful word editor for these lessons. But we would love some auto-population features from something like an online corpus or dictionary. So let's take a moment here as well. One of the things I mentioned before is we focused on feature completion over covering the full breadth of our scope. That's because this project is going to be continued on in future years, and we don't want to leave the project in a half-completed state where there's a lot of almost completed features. We want the next team to be able to jump in and immediately start working. Additionally, we want to focus on quality on each one of the features we actually did implement. Where we focused on user flows for our sponsors, particularly in the word editor, to make sure that it was fluid and to what he wanted. That being said, that meant our front-end features really lagged behind from our back-end development. Our back-end is very versatile and can support the full data model and breadth of the application and requirements. Just the front-end isn't quite there yet, but has the capabilities of doing so. The last thing that we didn't get a chance or opportunity to do was the usability testing that we had mentioned. Eugene was teaching a class this semester that we were going to be able to show off the product to, but we felt that the testing that we did with him and our sponsor, him and our coach, who used the product weekly, was very useful for the meantime. So lastly, I'd like to end it on a quote from our sponsor, from our last meeting we had with him, and open it up to questions.
Any questions?
Yeah, you said that when you created a practice and someone took it, got a grade, and then you went back and deleted the practice, it would delete their grade. Is there any reason why it could, why teachers just completely delete all the progress they had where it might have been one word that the professor would want whoever would want?
Yeah, so it would be inconsistent or unfair to give different practices to different students. Because the requirement was they were all taking the same practice. So a feature that's in the requirements that we don't have implemented here would be that when the professor goes to edit a lesson and students have already taken a practice, so they want to unlock that and edit it, they would be prompted that students had taken it if they had. And then the professor would decide, okay, do I want to wipe away all the grades, or do I want to just deal with this and fix it after the fact type thing. So, is that fact?
How do you deal with where, so you can edit things like the quizzes and courses that you take on those, correct? So one student might take it, get like 14 out of 22, and then after no one's currently taking it, they go in and edit it. Can you add more fields to that? So now it might be out of 25?
No. We just said, yeah.
It's the same reason.
It goes on a hard lockdown when there's practices that exist. So you can't edit the lesson while it's out there.
Yeah. Oh, sorry.
Have you tested and do you have full Unicode support for giving lessons in foreign languages?
We have not tested it. I believe it would work. That's the best I can tell you.
I tried this in Russian and Greek for other languages. As long as the whole system was able to provide Latin alphabets where you look at ideographs like Chinese, Japanese are not compatible. We're not able to figure out how to do it. But for Latin-based languages, let's say non-ideographic languages, pretty much the program is written the right way.
Yeah, the system would allow for that, and that is possible. It just wasn't in the particular requirements for this. So,
Yeah, we could copy the data. We don't have that implemented yet, but yes.
yeah, we had, you want to talk about the
Back end, yeah, so back end, we kept up, pretty much, I mean, it is covered 100%, we think it's, I mean, that's as far as code coverage, it is 100%, but, I think as far as like actually, it has caught, bugs for us before, and we've set up, our build so that the tests all have to pass, so with having so many tests in there, they do get run.
yeah, and reflecting back, adding some more tests to each front end would have been more useful.
So we don't have like much of any testing on the front end. We opted for going for TypeScript and saying type safety will be at least some protection against some problems. And then after that, UI testing is incredibly expensive. The amount of developer time that we would spend on it would mean that we'd probably be missing, I would say, about a quarter of these features. And we opted instead to say, we're having people use the application on a regular basis. Let's use that as our benchmark for now. And yeah, it has hurt us in the past. We've had some regressions, but I think overall we still saved a lot of time and maintained some pretty good quality. So.
Any other questions? Thank you.
Thank you very much.
Some cards and plug this in.
There you go.
So, no, we think, we can give it the HDMI world, but we think it's been disconnected in there. And I've got mini display port too.
Yeah, I think this thing has
So-
display for you.
So
Yeah, let's give that a try.
give that a try, and if that's not gonna work,
Input 3 and no wonderful.
Put it on HDMI.
HDMI is currently selected. No, there are no controls to displays.
all right, so let's see if we can go with the VGA then.
Yep, let's do that. Because otherwise, this is going to be a fun presentation.
Yeah, it's, you walk around holding the screen.
Yeah, everybody will see that. It'll go perfectly. Okay, yeah, I think that's screwed in enough. Okay. There we go. Something's happening.
That looks good.
Okay, yeah. Oh, is it already extended? Nice. I'm just going to change the display on this real quick so that it's usable. Oh. Okay. And let me just reset that pause. Okay, we should be good to go. Over there. Oh, right, yeah, my bad. Did not notice that. Okay, now we're good to go. So let's start this.
All right, hi everyone. We're Team Kwando. We've been working on the Tioga Taekwondo student management system. So the team, I'm Nicholas Coriel.
I'm Mike Washburn.
I'm Curtis Kelly.
I'm Andrew Vogler.
And I'm Andrew Dutt.
Our project sponsor is Paul Matan, the owner of Tioga Taekwondo, and our faculty coach is Dr. Scott Hawker. So today's agenda, what we're going to do is we're going to go through the problem context first and get everyone aware of the problem that our sponsor is trying to solve. Then we're going to go through the requirements at a high level that come from this problem. Then we're going to jump right into our demo and show you guys how we actually satisfy those requirements with our software. Then we're going to come back from the demo and go through the architecture, the challenges and trade-offs, the documentation we produce, the project reflection, the future goals, and have some time for questions at the end.
So our sponsor owns a small taekwondo studio in Waverly, New York, with just under 200 students in it right now. The main goals of the system are going to be to save student personal information, to track their attendance and rank progression as they earn belts and gain experience in taekwondo. And it's going to be to make daily tasks such as checking in as easy and quick as possible. Users of the system are going to be ages 3 and up, because students are also going to be users. And there was a previous solution, but it had limited capabilities, and so to make that better, our sponsor wanted a complete rebuild.
So our high-level requirements included the ability to track and manage student attendance, as well as their progression through belts and stripes. We had to be able to manage the student contact information, register new students, and manage programs and student enrollment in those programs. Finally, the system had to be easily usable by any user that it was 3 or older, and be deployed in a self-contained package.
And now we're going to go into our demo. This is our home page, and this serves as the navigation point of all the different functionality in the system. Right now we're unauthenticated, so we have less permissions than an authenticated user would have. And the first thing we're going to do is change the program to Taekwondo 9 to 12. This is the biggest program in the system, and we're going to check a student into this. So this is our check-in page, and the first thing you'll notice is that the color on the belts, or the color around the student's pictures, shows the belt color for the current belt that they have. To the right of each picture, you can see the stripes that they have. When they get a certain amount of stripes, they're eligible to test for the next belt. If you actually click the check-in picture, an image, it'll confirm, and then you can click yes. And it'll gray out their image, and it'll show it with a green check mark on it. You can also see the check-in count at the top. It shows a 1 now instead of a 0. So if you go back, another function that we can do is register or complete partial registrations for the system. A secretary of the system can go in and fill out a bunch of your information ahead of time so that you don't have to do it the day that you're actually registering. So if you do that, you can confirm that it's you by entering your phone number or email address, and then you can verify that all of your information is correct and continuing, and then you can read the waiver that we have, and you can sign it at the bottom there. Once you can verify it, you can register yourself in the system, and that'll be done. Now we're going to log into the system, and there's 2 different levels of users you can log in as, admins or instructors. And right now we're going to log in as an admin and go back to the check-in page. You can see that there's a lot more things that you can do as an admin. First, you can change the date that you're checking in with at the top. So if you forgot to check in a student for yesterday, you could go back there and fix that mistake. You can also filter by belts, so if you wanted to show all the red belts that are currently in the class, you can do that. You can check in students without confirming, so that if you see a bunch of students walk in at once, you can get them all real quick. And you can also uncheck in students here. At the bottom, you can also see all the instructors for the class, and you can check them in too, so that you know who's instructing that class for that day. At the top, in the right, you can switch the function that's performed when you actually click on a student. So if you click edit, and then go to edit a student, you can change all of their personal information. You can take a picture if you would like. And if you take that and upload it, at the bottom, you can also add stripes to the student, or you can change their current belt. So if we change this from red to green and then update it, then we can see the student that we checked in as now has a green belt. Another thing we can do is click to view a student. So if we view and then click on a student, we can see all of their personal information as well as different records of them associated in the system, such as their attendance. So here we can see every date that they checked into a class.
We can filter by program here or date range. To the right of that tab, we can see all of their achievements, which just shows a list of all the stripes and the belts that they've achieved in order. Belts are highlighted so that you can see them stand out from the rest. To the right of that, we can see the waiver. And if we want, we can create a new waiver and enter in a digital signature. And here it'll create a record that we can then take a picture of a physically signed waiver or upload a file if you scanned it. We can also see the student instruction records, which shows all the classes that they've instructed at. This just helps to verify how many classes they've actually shown up and helped taught. So you can go back now.
So now if we go into the program attendance page, this page shows all of the attendance in the system for every student. We're able to sort by program or a date range for attendance, as well as a student name. If we were to condense the list, it would show us a quick glance at the number of attendances a person had during the selected date range broken up by each class. And when we go back, we can now go to the student list page. This lists every student in the system, and at a quick glance has all of their necessary information by name, email, phone, and emergency contacts, as well as being able to filter by program, by belt, active status, or by an attendance date. As well, you can type anything into that search box, and it will grab any student that matches it from their name, email, phone, emergency contact's name or phone number, or really any sort of data that is in their profile that'll match against it. Now if we go back out and go to the belts and stripes. So belts have three fields associated with them: a name, a primary color, and a secondary color. The secondary color isn't necessary and will be filled in by the primary color if left blank, but it's needed for the multicolored belts. And we also give a preview of what it'll look like. And note we changed the red belt here. We also have stripes, which have a name and a color associated with them. And any stripe can go with any belt or vice versa. Now when we go back to the check-in page, if we go in there and filter by our new red belt, you can see the color has persisted throughout the system. Now when we go back and import-export, so our sponsor wanted to be able to export any system data for use with third parties or just record keeping, and we allow multiple different types of export to fill that requirement. We also had to allow for a backup and restore feature, so that if something were to happen with the system or the computer that it's running on, it could easily be restored into a new system on a different computer, or like an updated version. And when we go back, the modified programs. So we had to be able to adapt to changes in the studio's programs, be it new programs, removing programs, modifying programs. And here on the edit page, you can change the name, the active status, the instructors, as well as the program, or the students in the program. And as soon as you hit save, it persists throughout the system. So scroll down, that's now inactive, and we change the name. Finally, if you click on the username in the top right, a drop-down displays for all users. And every user has the change password and manage and logout options, though admins have the manage account option. And when we click on that, you can see our ability for an admin to modify any user in the system, creating, deleting, resetting their password, or changing their privilege level or username. And then we can log out. And it automatically takes you back to the home screen. And if we log in as an instructor, just real quick, so the tiles on the home page are different than that of an admin or an unauthenticated user. And this is just real quick to show the different sort of privilege levels that we accounted for.
All right, So that demo said and done, I'd like to I'd like to go into some detail about how we designed our high-level architecture in order to meet our sponsor's system requirements. So, to put it simply, we just took a layered approach to designing our application. Not only is this a relatively standard approach for designing web application, but this allows our various components within our system, our user interface written with AngularJS, our REST API, which we use Django, and on top of that a library for Django called Django REST Framework, and for our database we just use SQLite. All three of these components are relatively decoupled from each other. Only one component needs to communicate with one other component, so things stay relatively decoupled and things stay neat and not a mess. All three of these components are packaged into a single self-contained application which runs on a single desktop machine which is located on a Windows-based desktop that's in our sponsor's office, which is of course in his martial arts studio. In addition to this, a series of Windows and/or Android tablets connect to the system externally via the local network as denoted in the diagram. This allows both sponsors and instructors to walk around the studio as needed, enter any information, do whatever they need to do with our system without really disrupting the flow of a class or having to remember information to be recorded later in our system. So there are definitely some challenges to implementing our system. So there are definitely some challenges to implementing our system. A huge one for us is that our sponsors set out a really strong initial requirement of not wanting any sort of external connections to or from our system. So this basically meant we couldn't use any sort of external hosting services, any external database services, anything external. Everything our system needed had to be basically available within the local area network, so everything had to be self-contained. In addition to that, our sponsor also wanted the system to be able to be easily installed on any new system as the sponsor deemed necessary. In addition to that, we also knew right away that our system would be running on both desktop and tablet screen sizes, so we wanted to make sure that our UI was going to be able to adapt to both of those screen sizes relatively well. Another thing we noticed as development sort of progressed was that as the amount of data in our system grew, some pages experienced significant slowdown. We noticed that this was because our endpoints were performing a really, really large amount of joins, in many cases giving us data that was completely unnecessary for those certain pages. So we sort of worked around this by creating specialized endpoints that those certain pages called, and this reduced the amount of data that was being returned by the API, so this lowered response times and of course kept our application responsive, which was a huge priority for us from day one. And finally, in order to make taking pictures of students and getting them into the system an easier, more streamlined process, we decided to add support for the webcams built into the various tablets that were being used so that instructors could basically just point and touch. My turn. Still. Anyway. So, of course, with any software system, there were trade-offs to be made, and of course ours was no exception. A huge source of these trade-offs was adding support for aforementioned built-in webcams into the tablets. We didn't really want to get rid of this because not only was this a huge gain for usability for our system, but of course our sponsor really liked the idea, so we didn't really want to let him down in that department. However, we did notice that the library we were using sort of had problems with Firefox, so we sort of worked around that by simply dropping support for Firefox, and our sponsor ended up being completely fine with that and using Chrome instead. In addition to that, we also noticed that when you were trying to take advantage of the webcam feature when accessing the system from a machine that isn't your local host, that the webcam simply wouldn't work, and we realized that our plugin also required sort of HTTPS support, so we went around to adding HTTPS support to our REST API and, of course, creating a self-signed certificate, which, since our application is self-contained and operates only within a local network, we decided that was more than sufficient for our needs. And finally, instead of adding additional features beyond any requirements that were initially set out, we decided to emphasize testing and fixing any bugs that we found in order to create a better polished final product to deliver to our sponsor.
So at the start of the fall semester, our team and the sponsor agreed that we wanted to stop development in mid-April and cut our first official release. We decided to do this for two reasons. Number one, so that the sponsor could use the system in his studio while the five of us are still in school. And for a second reason, so we could focus on documentation. Pretty much since mid-April, we've pretty much exclusively been working on documentation. We feel that with this amount of focus on it and not worrying about implementation, we've been able to really polish and review these documents listed here so that should the need ever arise for anyone to come in and work on this system, the documentation will give them a huge advantage.
and so that we believe that we've improved these documents to the level that they will help our sponsor use the system on a daily basis.
So after documentation and implementation were complete, we sat down as a team to go over what we think we did well and what we could have improved on. For starters, we felt that following the evolutionary delivery model was actually very helpful. We were able to show our sponsor every 2 weeks a working prototype based on that current iteration, and that allowed him to give us feedback of things to incorporate for the next iteration. We also made good on our promise to add testing to our process. Last semester we had almost no tests. This time around we added a very large amount. We have much better coverage this time through. We also delivered all of the features from our initial requirements meeting with our sponsor, and from there we've actually added additional features as well. Along the way we achieved usability goals, and our final iteration was actually finished on schedule, which is a big goal we set as a team. We felt that our sponsor meetings were well organized, and it kept both the sponsor and the team in sync in regards to what's being worked on and what's left to do. Another big goal we set for ourselves was actually performing live user testing. So we had a few team members go down to Waverly, New York, and actually use the system with the real Taekwondo class. That gave us a lot of valuable feedback that we integrated into our system to help improve our usability. And lastly, we're happy that our sponsor is very happy with the product we provided to them. We could have improved in some areas. At the end of last semester, during finals week, we actually failed to deliver one iteration release. This is because we took on too much development work, and we didn't estimate correctly how long it would take in regards to both developing and actually studying for finals. Occasionally, we had insufficiently detailed wireframes. This made it difficult when it came time to implement the UI. There was some uncertainty there, and we had to go back into the drawing board and start over. Sometimes our team actually we didn't manage to merge our pull requests in time. This is because we had a self-imposed restriction of at least 2 approvals in order to actually merge a pull request. So this occasionally caused some PRs just to kind of hang out until people got around to it. And lastly, we had some issues with deployment. For starters, only one team member was actually deploying routinely. The other 4 didn't really know how to do it, so it fell to him to be the only one to deploy. We should have actually gone through and made sure everybody knew how to do that. And secondly, we had some issues with our final deployment, just in regards to actually getting the system to work correctly in our sponsor's environment.
So with all that said and done, what are our future goals for the product? In the next 2 weeks, we're going to be releasing the software as open source. We hope that the product is used every day by our sponsor to satisfy his needs. As we mentioned earlier in the presentation, previous implementation that was given to the sponsor did not satisfy all of his needs, and actually a lot of the code would end up being unused. And lastly, at the moment, there's no intention of development ever resuming on this product. It is in a completed state, but if development ever were to resume, we feel that these would be some of the issues that should be tackled. Add user action logging, improve security, automate the current program selection, and the Google Calendar integration, which some of you may remember we brought up as a stretch goal for this semester. And the team and the sponsor communicated about this many times, and we reached a conclusion that the cost of implementing the feature was not worth the benefit, and we decided to allocate more time to other features and more testing. So with that, any questions?
What were some of the changes that you made as a result of the user testing?
The user testing actually went pretty well. We found a lot of small bugs that I guess we didn't really pick up on by ourselves. We assumed that users would do something a certain way, like with a date picker, for instance. We thought it was really obvious. You click it, you click like the month again to like switch back to a bigger span of time. The users didn't really find that intuitive at all, so we just added like some formatting help to just type in a date.
Yeah.
Which is a lot more intuitive.
And in addition to that, we also noticed that in some cases we weren't providing some information that, in particular, our sponsor would find extremely valuable. So if you guys remember the check-in screen and how we had a basically number of students who are in the class versus number checked in, that was a direct result of our user testing. Basically, our sponsor requested on-site, hey, I think this would be really useful, and we sort of added it from there.
I think the other big one that we had was when we originally developed the UI, we left all the select drop-downs, their standard size, and actually using them on a tablet, that ended up being kind of an issue. When you have big fingers and maybe you're not used to working on tablets all the time, it was very easy to misclick. But we didn't really realize that until we actually did the live user testing. So we came back from that and worked on some CSS and got all the select drop-downs bigger for more optimal tablet use.
Does the system manage instructor schedules as well, or just student attendance?
It doesn't manage instructor schedules, but it does keep the records of when they checked in and attended a class.
That feature was discussed as part of the Google Calendar integration, actually. That didn't end up getting done. What the sponsor could have done would have been go into a Google Calendar for a studio and schedule all the instructors, and then the incorporation with the Google Calendar would have helped with the scheduling with the system, but that did not get done as described in the presentation.
It shows that the admin was able to delete other users from the system and edit other users. What was the? I didn't see that any capability of deleting any information from the database, like student information, was just set to inactive. What was the rationale behind that sort of
So our sponsor wanted to be able to persist all student data, whether they left the studio or not, in the chance that they might come back and attend, or even just for record keeping and keeping track of all that, and even having the contact information for possibly reaching out again in the future if they went to a one-time class, reach out again and say, hey, we have this other one-time class you might be interested in, and other stuff like that.
You mentioned that you had a trade-off between implementation, features, and documentation. That sounds great. You documented it really well. So how did you ensure that the documentation was up to par with members of the community?
So what we did with that was we kind of followed the same mantra that we had with our actual code, where we required when we had a pull request, we required 2 people to have eyes on it and test it before we would merge it. We attempted to do the same thing with our documentation, so that way when someone said, hey, I'm done with this, 2 other people had to sign off and say, yeah, that's up to the quality that we expect it to be.
Were there any unique things about open sourcing it that you considered?
There were a few instances where, I mean, the easy way to implement something would just be to do it the way that is specific to Paul. But, in the interest of open sourcing, we took the extra 10 minutes or so and, extracted it out into like a configuration file or something like that.
I'm curious also, real quick, you're open sourcing it, but who's going to, is there a particular community or stakeholder or someone with the interest and ownership of the code base?
Not at this point.
I think,
Yeah, I think that would be Paul.
I think our sponsor Paul has some people who he wants to reach out and say, hey, I have this cool thing that's open source. Do you want to see if it'll work for your studio? But the team is not aware of any of the moment. So that's the team.
No, we'll meet every which way. We've got to go with VGA, so here's a mini display port adapter to VGA. The HDMI does not appear to be functional.
I knew I shouldn't have brought that up. Should we be screaming or just like?
No, just speak up. You are proud, you are Marines, no, you're not Marines. You're proud and you are wolf. So wolf it up.
It does feel like there's nobody here.
Yeah.
Good feelings.
Oh my.
That is big.
Let's fix that a little bit maybe. Hang on. I done this last time we did this.
Oh, that's better.
Well,
Oh.
A little bit better. Why is it?
Can we just full screen it and see what happens? Like it might just be. Yeah, there we go.
Okay. It's quite large. All right. Hi, we are Team Woof. I'm Courtney McGorrell.
My name is Luke Harold.
I'm Colton Venditto.
I'm Derek Young.
And to kick things off, we want you guys to imagine that you are the managers of a farm and take a minute and consider all of the things that you would have to keep track of what you're growing, where you're growing it on your farm, how long you're growing it for, what's happening between sowing and harvesting, how often are you watering, weeding, how much is coming out, how much are you harvesting, and then where is it going after you ship it out. So to explain how the Wegmans Organic Farm is currently tackling this problem, Luke is going to walk you through a couple of these spreadsheets.
Okay. Well, based off your reactions, I can see that you guys might be a little overwhelmed by this, but this is actually the highest level part of the system. So right here is just going to be the where and when of the crop. So this is going to have the important information as far as when did you plant it, so you could get basic estimates off of it and relevant information like that. Getting a little more granular, we're going to move over to tasks. So in order for Wegmans to keep their organic certification, they have to keep a certain level of traceability and record a lot of information on what happens to the crop in almost any aspect, including what materials were used, when, and also this doubles as labor tracking. So this is the main point of the task reporting. But if we were to go on to distributions, this would be the last part of the system. This needs to be maintained in case of product recalls. So when the crops are harvested and bundled up and sent places, Wegmans actually has to keep track of where they went and where and when they went there. So these three spreadsheets together tell a story of seed to store, but there's also some difficulties brought up with the current system. First of all, being usability. As you could imagine, unless you're a single domain expert on this, you might have a very hard time navigating that, and even if you're not trying to input stuff, just trying to read the information on those spreadsheets might not make a lot of sense unless you're very well versed in it. This also doubles as the way the current process is working is it's a single user on a single computer, which represents a huge bottleneck in the system. Another thing we have to keep in mind is the separation of features. So those three spreadsheets all accomplish different tasks, and it had a very hard time, you have a very hard time tracking something from when it went into the ground all the way to when it shipped, considering that a lot of the interrelated data is stored in different spreadsheets, which ties into the last one, which is the separation of data. A lot of the traceability needs to make a lot of sense for reporting, and in order for the system to actually come through, we need to make sure that it tells a story that can make a lot of sense. So Wegmans, with these three goals in mind, came to us with a lot of requirements, which we've boiled down to these three. First of all, being traceability, obviously. We need to be able to see the entire system in a pretty reasonable manner. Also, data retrieval is a huge part. So not only just going through and navigating the system, even if you know what you're doing, it might be pretty difficult to just go and find one specific aspect. So we want to be able to make sure that if the user knows what they're looking for, they're able to get it reasonably well. And also usability. As you can see with those spreadsheets, you would require a lot of domain knowledge and expertise with Excel to have a productive time using that. So these were some of the goals that we wanted to accomplish with our product. So if we go on to the next slide, with the product that we delivered, we feel we brought value with these 3 points. First is the efficiency of the data entry. With the spreadsheet, it was a little complicated and hard to follow, but with a web solution, you're able to just input data in a lot easier manner, as you're going to see with our demonstration. Also easy to consume data, so rather than going through and meticulously adding single rows to a bunch of spreadsheets, if you just have a simple page that presents the information in a coherent way, it'll make it a lot more productive. We also need to make sure all the historical data is stored in one place. Like we said, we want to be able to tell the story of seed to store without having to jump through a lot of hoops and navigations. And lastly, we want to empower the farm staff. So a lot of these users aren't necessarily technical users, so we wanted to make sure that even if they didn't have a lot of the know-how, they were able to just jump into the system and be able to reasonably be a productive user and get what they need done.
So our software is a single standalone application using no third-party web server. As you can see, the user is going to open the web browser, and using the web browser, he's going to access the application and interact with the application to manipulate data in the database. And this is our standard MVC design pattern, but instead of just one controller, we have two controllers. The Angular controller acts as a traditional controller in our design pattern, where it calls the .NET Core controller, where it acts as a web service and API calls. And getting that data, the Angular controller renders HTML views with the data, and the user can manipulate it and thus save changes into the database.
All right, so tying all of that together, instead of bombarding you with all of the different kinds of data that we're capturing throughout the application, I'm going to take you through one typical workflow that would take place over a couple of months, a couple of weeks, depending on what you're actually growing. So to kick things off, I have a new piece of land that I've built a high tunnel on. And a high tunnel is just kind of a small greenhouse that can either be used to grow things in trays or grow things right in the ground. It is about 50 yards long, so it's about 100 feet, 150 feet, and it's about 80 feet wide. So using that, I'm going to build a plan from it. I'm going to grow some mint. I'm going to go find my plot of land that I just used. And I'm going to make 9 beds that are about 4 inches wide and space my plants 2 inches apart. Next up, I need to plan out when I'm going to sow and when I'm going to harvest. So let's say that I'm going to sow tomorrow, and I know off the top of my head that mint takes about 90 days to mature. So I'm going to estimate that next date, give it the type harvest, and you'll also notice on the side here that it's given me the total number of plants that I'll be expected to put into the ground for myself. So I submit that. The next thing I would want to do, going about daily life on the farm, is I probably would want kind of a list of to-dos for the next month. So for May of 2017, I'm going to export all of the tasks that are meant to be happening, whether they've been completed or not. I just want everything, and I'm going to export that and get it into a CSV file, which I can then import into any typical spreadsheet viewing application, manipulate it the way I want to, print it, give out hard copies so that people can have it all across the property, and they're not confined to the computer for this. The next thing I'm going to do is report on some of the tasks that are being completed. So I actually got to sowing my mint a day early. We're doing it today. Spent about an hour and 15 minutes on it, and we did it back in that high tunnel that we made at the very beginning. So if we go back and take a look at our plan, you'll be able to see this is our growth stage. A plan can have multiple stages. So if you start something in some small trays, create some sprouts, and then plant them into the ground, that would be represented over 2 different stages. But we're going straight into the ground and then straight out again, so we only have the one. You can see the tasks, the one that we just marked as being completed today, as well as our harvest being planned down the road in August. Next, we're going to kind of fast forward, pretend that we're already in August. And we're going to start wrapping up. So when you harvest, it goes into a harvested lot. So I'm going to build a lot from everything that I harvested on August 2nd. And I only have bagged mint. And I have 2 cases of second quality. So quality just talks about the general quality of it, the size of it, how much of it came out, And that can determine where it's going to be shipped out to, whether it's being shipped to you, the consumers, who are buying it in the grocery store, or maybe to a restaurant who doesn't necessarily need the nicest looking crops, just the ones that taste as good. And quantity is represented in cases, which is a standard unit used on the farm. And after all of that, I'm going to submit, go back and check on my plan. And you can see my lot just popped up. So the last step, I've harvested out into the lots, and now I'm going to ship it out to some customers. So I'm going to build a shipment just to the Rochester Wegmans. We're still working in the month of August, but we didn't get to shipping for a little while. And that's pretty much the flow from creating a new lot, or a new plot, excuse me, all the way through to shipping.
So we've taken a number of steps to make sure that our project is in a good enough state to hand off to our sponsors by the end of the semester. And the first of these steps is reformatting the code based on our sponsors' opinions, inputs, to have it be more readable and understandable so that future developers will have an easy time manipulating the code. We've also are setting up a basic guide to the system that will include how to set up the system as a whole and how to set up any subsystems that need their own special instructions. It will include flows for users so that they know the general path of how they want to accomplish certain tasks within the system, and flows for developers so they know how to change or test the system without causing any issues or system failures. We have no packaged delivery for this system because it has already been with our sponsors for quite a time now. It has been on Azure servers, so they can deploy and manipulate the system already. We've come across a number of challenges throughout this project, mostly in terms of inflicting problems with our schedule. The first challenge is that we had to start from scratch. We had no prior work. We had nothing to base the system off of. We had to go establish the system purely on the elicitation process. So we made the foundation, all the different parts of this project based solely on sponsor input. We've also had to work with technologies we weren't all familiar with. Generally, at least one person in our team has been familiar with every technology that had been used to make up this project, but there was no technology that every person on the team was familiar with. For this caused us to have to spend time teaching each other different aspects of each technology to make sure we're all proficient enough with them to build up the project in the way it needed to be built. This was a very good learning experience for us, but it definitely aided into our development time. We also had to learn to understand our domain farm management, as we did have an experience to go out and see the farm and see how it ran behind the scenes to a certain extent, which helped us. But even with that, none of us have any prior experience with farm management, so it took us some time to wrap our heads around that. And just general academic responsibilities of being a senior ate up our time. Department deliverables such as 4-ups, project plan, technical reports, poster, interim presentation. This presentation has taken time away from our development process, as well as reports, projects, and assignments from other courses have impeded our progress.
So the future of this project, Wegmans is going to be taking it on for the foreseeable future. They have a couple interns coming on this summer, one of whom is our very own Derek, and they will be kind of spearheading onto the project, taking on a few key features that we weren't able to bring to fruition for this year. The first of which is authentication. We have a really good jump start on it, and I think it'll be a really quick fix for those interns once they get into it. And then getting more experience beta testing with the users. So once they flush out a few remaining bugs and getting it in front of the users who can click through, give their own input and ideas about how the system should really flow. And then there were a number of other nice-to-haves that were dictated to us at the beginning of the year that we put out of scope for ourselves, but could very easily be considered down the road. And that's all we have. Are there any questions? Yes.
You talked about challenges, and it was like, seemed like it was less technical than challenges, but it looked like the amount of data you had to store was pretty large. Did you have any challenges around like creating the whole database schema for that, considering there was so much data around that?
The short answer is yes. The long answer is it was extremely difficult coming up with a database schema to involve all of that. It was refactored probably no less than 5 times in fall semester alone. It was something that we sat on a lot and very often and continued to have to refactor as we learned more and more about how the data kind of related to each other. So it was a huge difficulty. Yes.
You have a pretty robust product that has like a lot of different features, and as you mentioned, farmers aren't necessarily the most technical users. Did you consider potential onboarding or other ways of helping the user understand the new system?
Tooltips and a basic guide page was one of the features, was one of the nice-to-haves that we kind of put out of scope. It's something that makes a lot of sense to be adding in, especially guiding the clicking around. A lot of the kind of click-through, as you enter each page, they'll all have that big table that shows you kind of everything and the add and export. So there's a lot of familiarity across the pages, but tooltips and some kind of how-to guides were something that we wanted to do but just couldn't find the time for.
We also tried to model a lot of the system based off of what was already in place. So I think the users, while they might not be technical users and this might be like a brand new product, they do have a foundation. We tried to get, despite us not having a lot of domain knowledge, we tried to make it as accurate as possible, I guess I would say.
Yes, Brian?
It seems like users have a lot of access to all of the data in the system. Are there any kind of security concerns? You know, is this user going to come in and change my plot even though I haven't harvested any crops?
Security itself isn't the largest concern. One of the pieces of authentication is that we wanted to create essentially a super user account where we could restrict certain things like editing plots, crop types, task types, sort of the things that are static and that are used to build up crop plans and the more dynamic things. So that would be more of an admin type role that we wanted to facilitate, but because we couldn't get authentication to happen, we weren't able to separate those two out.
We did have a lot of discussions with the domain expert, like the person who was basically behind the spreadsheets, and we did voice a lot of concerns. We framed a lot of questions saying like, do you want this to any user to be able to do this or that, but as we got discussing, it seemed to be they wanted to prioritize more of letting anyone do as much as they can rather than restricting any features based on any sort of role.
Any other questions? Okay, thank you guys.
Thank the team.
He's like a
Come on.
I don't understand what he's doing. You're a stage mom.
Nice job, champ.
Good luck.
What's up?
That's what you gotta go with. The HDMI doesn't appear to be functional.
Well, let's hope that I've got nothing but appropriate things on my windows left. Whatever you've done.
Can you make sure that we've got presentation notes?
Your sponsor's not here, right?
No, they're online. They're here in
So we'll wait until 5:15 in case they're coming in at the last moment to catch it.
Are you gonna tell some jokes to follow time? Are you gonna tell some jokes?
Yeah, I'll tell you, or you can just guess. It's 5:11 now, so you can.
What? Yeah, I do.
Oh, you do need them. Okay, that might be. Dr. Rack, you PLC right now?
Just wait, pull that back over here.
Yeah, I'm gonna.
And then present.
I'm just gonna copy it. And I'm gonna. Oh, I see what you're saying. So we're gonna do you. This one? Display? No, you have to go to, if you want to extend the... No, you don't. Hello, everyone. We are Team Pager Nation, and we're going to talk about our escalator that we've been working on. My name is Brian Wilkins.
I'm Caleb Davis.
I'm Jared Lee.
I'm Kevin Moses.
And to give you an idea of what this project is, whenever a system goes down, which, you know, all of our software is perfect, it never goes down, but other people write software that goes down, someone has to be notified that this system has gone down and make a fix, whether it's, you know, database or some sort of deployment. And that can be kind of a hard problem, knowing which person to notify at the right time. You know, you don't want to always be the person that's on call. So we have this idea of a paging system where when some sort of ticket is created in the system that is some sort of emergency level and needs to be fixed as soon as possible, it needs to go to the right spot. And most companies have something that exists. Some of you are familiar with PagerDuty. Liberty Mutual has XMatters. And all it does is just send a notification to a group. The group kind of figures out who has to be paged. And that is done through what we call an escalation policy. You can see up here, we have Alfred, Betsy, and Carl. And this is kind of a mock escalation policy. Alfred gets an email, he gets a phone call, he gets a text message. He's the first one on call, and he doesn't pick up. Well, normally, it would just die. No one would be notified. But because of this idea of an escalation policy, it's going to be escalated up the ladder, and Betsy's going to get a phone call, she's going to get a text message, she's going to respond, and now the ticket is being resolved. Carl has no idea that this problem even existed because Betsy is on the case.
So as Brian was just mentioning, our problem boils down to replacing their existing software called XMatters with a system that is tailored to Liberty Mutual's specific needs, which are outlined in gray here. They are to accept requests from Remedy, which is their ticketing system. That's the system that knows when an application has gone down, and it will create the tickets around that. We also needed to allow users to set up their own personal alerting schedules, which includes setting up which devices to page and which order to page the users in. And finally, alerting users in the order of the escalation policy when the application goes down. So that's actually sending out the email, sending out the text, sending out the phone call. And then in addition to those already existing requirements, the sponsor wanted to also see a heavy focus on usability. Their current system is in the screenshot on the right, and this is actually like 3 versions like newer than the application that Liberty Mutual is using. And you can already kind of see some of like the main pain points. It's a little bit fuzzy here, but there's a delay in the like far right. And it's kind of unclear as to if that delay is before a page gets sent to the home email or after, or you know, there's confusion there. So basically, XMatters has a lot of features that Liberty Mutual wasn't using, and a lot of features that are kind of difficult to use. So we focused on creating a system that's tailored just to how Liberty Mutual employees will be using it. So here are some high-level requirements that we had decided on at the very beginning of the project. This was agreed upon between us and our sponsor. Essentially, there are 3 different user groups that all have different levels of permissions and different functionality. A regular user is just someone who will create an account, join a group, and set up a personal escalation policy so that they can be paged whenever an application within their group goes down. A group administrator is a user who is in charge of any subset of groups, and they take care of setting the escalation of users that get paged within their group. And that includes adding people to the escalation and removing people, scheduling removals, etc. And then a system administrator is basically able to view everything. They view logs of everything that happens in the system, including paging, or pages that get sent, including all groups, all users. And then they're also able to change user permissions, so upgrading users to system admin. All of the requirements in green are the ones that we're about to show you in our demonstration, and the ones in orange are actually requirements that changed throughout our project. So, for instance, creating accounts using LDAP credentials, we have the ability to create accounts, but our sponsor decided that instead of having us write the LDAP integration, they would just use one that is in-house that they have already. And then adding company holidays, our sponsor realized a little bit into the project that if an application goes down on Christmas, someone still needs to be notified so that that problem is known. So that requirement was also taken away.
So we're going to hop into our first demo now that you know a little bit of what's going on in our application.
So this is the screen you see when you first get to the application. It's a basic login form.
You have to go back a
Okay.
slide.
One more. They said video demos wouldn't go wrong. Anyway, this is still the wrong one. You just went back to the beginning of the video. Keep going. Slide forward. Now
Okay. That's it. We did it. We're on it. Right one.
Okay. Is this all right?
Yeah, this
it
is
should
us
be.
logging in.
Okay,
Sorry.
so we're going to head up and create a new user. This is the first thing anyone is going to do when they first start using our system. So it's just entering very basic information. It's a little bit fuzzy up on this screen, but basically it's just their name, their email, and then they're setting up a password. So once that user is created, they'll head into our system. It's a little bit blank right now because they have no information, no devices, so that's the first thing we're going to do. We're going to head to their profile, and you can see first off that all their information, their name, their email, this can be edited whenever they need to. So all you have to do is click on any piece of information, change it in line, hit enter, and it updates instantly. So we're going to add our first device. This is the first thing that you're going to get paged on when something happens and you're up on duty. So we're going to add a phone. You just give it a name and enter the phone number and hit create. And this is the first item up in your personal escalation policy. All the details are also editable in line if you ever need to change them, as you can see. So we're going to start adding a couple more devices to kind of build up our personal escalation policy. Next, we're going to add an SMS device. Looks very similar to adding a phone. All you have to do is give it a name and put in a phone number. And if you get paged on this device, it'll send you a text message that something is wrong. So now that we have that created, you can see that there's a interval in between those. We'll get back to that in a second. We're just going to add one more, and that's an email. So again, with the other ones, something goes wrong, and you prefer to get an email sent to your inbox first, that can happen. So we got that entered. And now, as I said before, you can see there's an interval in between devices. You can change this to set the time between, what the time it'll wait between sending pages to each device. You can also reorder them by simply dragging them around. You can note that the times stay the same in between them. Those are independent of the devices. So now that we have our personal escalation policy set up, it's time to join a group. So the user is going to find the group that they belong to. They're going to search for it and find it in the list. And they're going to hit send a join request. So when you join a group, it has to be approved by that group's team leader. So that's what we're going to show you in the next video. We're going to be logging in as that group administrator and show you some of their functions. So there's their email. They're just going to log in. And you can see on their homepage now, they have a link to one of the groups that they're a part of. The first thing you notice on the page is at the top, there's the basic information for the group, the escalation order, so this is the members of the group, and what order they'll be paged in when the ticket is created. You can see that there's a join request under administration from our new user. We approved that, and now you can see that they're in the not on call list. If you want them to join the escalation, you simply click the button and they'll move over and add to the end. If you want to manually reorder people, again, you can do that by clicking and dragging. This is also rotated once a week as well. So when you want to remove people, that's easy too. You just select them and hit the button, and they'll be sent back over to not on call. You can also do a delayed removal. So say someone is going on vacation or is on a meeting, and they need to be taken out of the escalation temporarily. You can set up a date that they want to be removed from the escalation at a time, and optionally you can have a time that they're going to be re-added as well. And once you create that and hit remove, it'll have a note on that user indicated by the little clock that they're going to be removed at this time and re-added at another time in the future. So it's flexible in that people can be removed and added automatically when real life gets in the way. So under administration, we have a couple other tools for the group leader. You can add and remove other administrators to the group. There always has to be at least one group administrator, so you can't remove yourself, but you can manage the permissions of everyone else in the group. And that's all for the group page, and then Jared is going to show you what actually happens when a ticket is created and people start getting paged.
Ooh. All right, so what we're going to go over now
is the whole flow from receiving a ticket in our system and then starting sending the pages out to the different employees on that escalation policy for a group. And so the first thing I want to point out here is this is the group page that you just saw before, but as you can see, I'm the one that's on call, and the last ticket action for this group, the core systems group, was a ticket that was acknowledged by me a day ago. So once, what we're going to do now is we're going to send out a page or a ticket to this system, and it's going to start sending it out. So what we've done now is we've gone to this group page that's just got an alert sent to them. And so what you're going to see is I'm going to receive an email in a second saying that something's wrong, and there you go. So the public API is delayed. So that's something I need to fix. And let's just say I've already fixed it. So I can go to this open tickets, see that this ticket here is open, and it gives me some brief information about it, and then I can go and acknowledge that ticket. When I acknowledge that ticket, it cancels all future pages for that ticket sending to people that are further in the escalation policy, and it will close the ticket as well. So once we go back to this page now, you can see that the core systems group's last action was that ticket I just acknowledged a couple seconds ago. And so what that gives is just a brief overview when you're looking at your groups of what's going on in each group that you're a part of.
They never said that demo can be perfect. Okay. So along the way in our project, we made a couple architecture and design choices that were basically based on three main goals. The first is separation of concerns. When we started this project, we understood that the scalability was going to be important. We want the API, which is going to be handling the bulk of the tasks and the requests, to be scalable independently of the rest of the application. Therefore, we have a separate queue, which the API sends in all the escalations when a ticket is created. And when they are up for being paged, it comes back to the API. So all it does is a scheduler in itself. So once we offloaded that functionality, we're now able to scale up and down the queue or the API as needed to handle the amount of requests that they're getting based on the number of users they have. And this modularity also allows us to interoperate different parts of the application and exchange them out if they ever need in the future. Since the API and the queue and the UI are all separate from each other, if we ever wanted to swap one out, say you can have a new queue that's a third-party based, that can be easily swapped out. If you want a new interface, like a mobile application or a command line, that can also easily be added. So by separating all these things out, we enabled all these things to happen. Secondly was maintainability. We're passing this off to Liberty Mutual, but we're not going to be the last people to work on it. They're going to want more features. They're going to want to fix bugs. They're going to want to tailor it to their process as they start to use it among their thousands of employees. So we wanted the code to be self-documenting whenever possible. We want someone at their company who has a basic knowledge of JavaScript or any of the other technologies we're using to be able to read our code and understand it. So besides written documentation, having clear data structures, API boundaries was important to us. Third was extensibility. Again, they're going to want to add new features, so we wrote it in such a way that new alerting methods, for example, can be added. Say they want to send push notifications or swap out external APIs. Right now we're using Twilio to send our emails, texts, and phone calls. They might want to use their own SMTP server to send emails. They might want to use an internal service or another third-party API to send those phone calls. So the application can interact with any of these easily and be able to swap out.
So going off that and more into our challenges that we faced, there was a couple main ones that we felt stood out. And so the first one is using a non-relational database, which is something that at the start of the product and when we're going through requirements with our sponsors, it was kind of something that I think we didn't look into as much as we should have, that's for sure, as well as it's something that they use currently. And so that led to a point where we knew that if we built it with that they'd be able to just pick it up and keep going from there. And I think looking back on that now, it's definitely, we definitely should have looked into that a lot more and also done some of
some more of the UI mock-ups and designs up front instead of waiting a bit to build them. And that's because as we got further in the project, we discovered that like the schemas that we felt were going to contain all the information for a certain page, where for a certain page, say like that groups page that you saw, the initial one, where it had like the ticket actions and all the groups you're a part of, we felt like you'd be able to get all that information from one single document, so essentially like a row. And as we got further and further on, we realized we wanted more information on those pages, and it just kept getting to a point where we're essentially doing populations across documents, which is just, imagine it like a join. So we got to a point where you're essentially just doing joins. So we were treating like a non-relational database like relational database, which wasn't ideal, but at the point we're at, it wasn't worth the effort to just go back and rewrite everything, considering how far along in the project it was and how many features we had left to do. And that kind of leads into the next 2 points, which were scheduling and the teams that we broke into. So originally we scheduled to finish development by the start of April, so just sometime just after spring break. And as we got closer to that deadline, we realized that although some of the features, most of the features on the back end were done, the UI was kind of lagging behind because we started a little bit later on that. And then from that, that kind of led into a lot of issues or it was caused by a lot of issues from this third point, which was breaking into 2 different teams. So we split into back end and front end teams, so 2 and 2. And then the problem there with that was that we felt there was like a communication breakdown between the teams, where the back end would build something one way, and then the front end would think it was going to get built a little bit differently. So we'd have to go back and change something once both of the products are built, and then to make sure that they fit together nicely.
So future goals for the project, we're delivering a fully featured product. If it is an open source product, if you want to bring it to your next company and say we're going to replace PagerDuty and save you $20,000 a year, you can 100% do that. You would just have to follow the same steps that Liberty Mutual will be following. So deploying to their cloud servers, integrating their current ticketing system so that it makes the API calls and will send out those pages. And finally, migrating any existing tickets that they have in XMatters to Escalator. Along with that, we have kind of a major feature of when you get a text message or a phone call, having the ability to acknowledge it right there on the spot through the text message would be absolutely fantastic, but unfortunately we didn't have enough time to get to that. Along with that, another stretch goal is to create some sort of Android or iOS application. Most people are going to be receiving notifications on their phone, so being able to, again, respond directly there, be able to update your escalation policy through your phone, those would be fantastic usability pieces that we just didn't get a chance to implement. So, that's pretty much it. Does anyone have any questions? John?
Yeah, you said you want to deploy the application to their cloud servers. Has it not been deployed anywhere yet?
So they just pretty much said, as long as you develop it and you can run it on your own, we will handle deploying to, they're using something called Cloud Foundry. Cloud Foundry, yes, exactly. And so they said, don't worry about deploying, we have our own people to set that up and we'll figure it out. As long as you can, the setup instructions are easy enough, we should be able to figure it out.
We currently have it, like we have a AWS instance that we have it all running on, a couple for the UI, the API, and the queue. So like we can deploy it to our systems automatically, so it's just a matter of like porting that across to theirs.
Anyone else? Courtney?
What other kind of documents are you passing along to the sponsor in terms of being able to take it and go with it now that you guys are kind of hands-off having it?
So most of the requirements documents, as far as what this system needed to do, will be handed off, along with the repositories themselves are fairly straightforward, and the documentation that we created around that kind of explains anything that's happening in the system that is complex. Along with that, just kind of any architectural diagrams as to how we think that this system could work in the future. So how could you hook up an Android application to work with the API? All of those things are kind of just listed out with that. Anyone else? I think I saw.
So
So I saw a little bit about how you guys mentioned you might be integrating with some of their current systems. Do you guys kind of work with their ticket management system or anything like that to automatically save these ones, or does it have to be done through your system to start that way?
So at the moment, the way that their current system works between Remedy and Xmatters, which is their ticketing and their paging system, is when a ticket is created in their system, so in Remedy, it'll send a request to Xmatters, and then that will start off that paging process. And that was the requirements that they had for us. So it's going to be the same thing, where we'll just accept some requests from them, and then we'll start paging from there. So actually creating the tickets isn't handled, like the ticket itself in their system isn't created by us. So we're just receiving that ticket from them and then sending out pages and closing the ticket accordingly. Currently at the moment, no, it's not set up to do that, but like the way that we've set it up on the back end, you could easily send any amount of the like different statuses for that ticket, and that would be able to work. So that's merely just something that they are nice to have that we didn't have time to build right now, and it wasn't part of those requirements.
And keep in mind too that when we acknowledge the ticket through our site, that's acknowledging the ticket that was created in our system. It's not like doing anything with the ticket in Remedy. It could be set up to close both of those, but currently it doesn't do that.
Any other questions? That's it. Thank you guys.
Thank you. We've been.
All right, everyone. We are Team Race Shipper 2.0. I'm Matthew Crawford.
I'm Kyla Lee.
I'm Colton Dennis. I'm Sam Schiffman.
All right, so we'll go over an agenda real quick. First, I'll go over the problem overview and the software solution. Sam will go over the architecture and design decisions. Kylan and Colin will show us the delivered product and some of the features we did for the app. Sam will go over the demo, and I will finish with a reflection and future goals, and then we will field any questions you guys might have. All right, so a quick overview. So Trillium Health holds fundraisers that often involve running and biking events. These events are usually held out in the middle of nowhere in the Finger Lakes region. They might be hundreds of miles long, so there's a concern for safety for the participants in these events. And so currently, the staff members who are working on the event will go out ahead of the racers and set up checkpoints. That might be medical checkpoints or just checkpoints for signing people in. And they'll sign people in with just a piece of paper and check them off. And so this isn't the most efficient solution, so a solution was needed to automatically keep track of participants to ensure their safety and to connect participants with the staff during the race. And our sponsor eventually intends to release this final product for use on similar events. All right, so our solution is an iOS app for the staff members. Each staff member who is using the app is represented as a checkpoint on a map. And these checkpoint locations are updated real time on the map if the checkpoint moves every over 10 meters. And then the checkpoint location are broadcasted to all other devices logged into that event via socket communications. So all checkpoints will be able to see all other checkpoints on the map. The app tracks participants with Bluetooth beacons by detecting when the beacon is within range of the device that's running the app. And this is done through polling. So the app polls for beacons that are within range every 5 seconds and automatically checks in participants who are associated with that beacon. If the participant doesn't have a beacon, they can always check them in manually. And so the iOS and server keeps track of checkpoint locations and participants last seen at that checkpoint to ensure participant safety.
All right. So I'm going to talk a little bit more about the iOS app. So all of the iOS development was done in Swift, more specifically Swift 3. Our front end, we employed a model view model design pattern. We have a middleware layer that is a collection of singleton services. Each one of these is responsible for a specific function or set of functions. For example, we have the gimbal service, and that is responsible for all of the Bluetooth communication with the gimbal Bluetooth beacons, which is what our sponsor plans to use for his event. Another example is the location service. That is what that's what updates the location of the current device to the back end and helps track with that. All of our networking goes through a singleton HTTP manager, and that's what does all the communication with our server on the back end. So some of the big design decisions we had to make were as follows. So we needed to separate out the business logic from the view controllers. When we inherited this app from last year's senior project team, they had employed what I would call an MVC architecture, massive view controllers. All of the code for the entire app was done in the view controllers. That's not maintainable. It's not, not very good practice either. So we wanted to separate all that out. So we decided to use singleton services. The services also help to make the app more extensible. For instance, our sponsor plans to have the app work with multiple different types of devices in the future. So to add a different device, all they would need to do is make another service to interact with that device. We also isolated all of the networking calls to one file to loosen the coupling between our app and the packages that we're using. All of our networking is done with AlimoFire, which is a CocoaPod, which lots of apps use for networking, lots of iOS apps, I mean. That was all over the app when we inherited it. So when we encountered issues migrating to Swift 3, there was a ton of issues with AlimoFire. So by separating that all out into a single service, we were able to make it easier to change in the future. Now, polling versus sockets. So since this app is going to be used a lot of times out in the middle of nowhere where you don't have Wi-Fi and you're just using your cell phone's data plan, we wanted to minimize the amount of networking calls that were being sent out. So for the beacons are automatically detected by the phones. But that information is not gathered by the rest of the checkpoints until every 5 seconds when they poll to the back end to receive all of the checkpoint information and all of the beacons or racers that are associated with those checkpoints. Sockets, however, we're using for the checkpoint location updates because those we were able to limit to only update after the checkpoint has moved a distance greater than 10 meters. Lastly, we did a major UI overhaul, and that was to make the app conform to iOS design guidelines for future publication to the App Store.
Next, we're going to take a look at the actual app that we developed. Here you'll see on the left the first view that the users presented when they opened the app. There is a list of pre-configured events that we pull from AWS, which hosts our backend information. From there, if you select an event, you'll be navigated to the view on the right, which gives you a selection of different user types, which we treat differently based on whether it's staff or event organizer, participant, or spectator. If you don't choose one of the events that have been pre-configured, you can also create an event, which will set you as an event organizer from that point forward. From here, you'll see the view that's presented on the left once the Create Event button has been selected. You're informed that you are going to become an event admin from this page, and you're presented with a Facebook OAuth login button. We use that to kind of keep track of their users with their unique Facebook ID to have authentication for when logging into events to make sure that the wrong people don't have access to event organizer functionality. Once Facebook OAuth has been entered in successfully, you'll be presented with the view on the right, which shows our Create Event page. There are a couple of fields of import here. There is the PIN number field. You can't quite see it because of the lighting, but this is a number that's created by the event organizer used by staff members to log into specific events. Down at the bottom, you'll see the route number. Can't quite see the field, but we use a third-party website called RIT GPS to get our route data. From there, event organizers can create a route based on the map and drop pins. And once that route is created, we're provided with an ID that can later be used to retrieve that route's data. And that sort of data includes the specific route and also elevation data so that users can see if they got a big hill coming up soon. And next you'll see the login view for the staff members, one of our supported user types. So this happens once an event has been selected and the staff button has been selected. The race ID is automatically populated from the event that you selected. You enter the PIN that is provided to you by the event organizers on the day of the event or leading up to the event. Some important fields here are the checkpoint name. This is used to uniquely identify the different checkpoints on the map view, which we'll see in a minute. All that is automatically populated with the device's name. This can be modified by the user if they want to, but this just prevents having to enter as much information as possible to get them into the event and to get staffing. So there's different checkpoint types you can also choose since we have to support different types of staff members. These include the SAG crews, which go around and ensure the safety of participants by checking them in. That's their main focus. But we also have places like rest stops, mechanical stops, and medical stops that we also want to keep track of. And those are indicated on the map view in the next slide as different icons so that users can know where these different stops are.
So the first thing you'll see when you log in is the map view. This shows the route of the event as well as a green pin for the starting location and a flag pin for the ending location. So we pulled this from ridewithgps.com as mentioned earlier. You'll also be able to see checkpoint pins for all checkpoints that are assigned into the race, which can be one of 4 types. They have different icons based on what type of checkpoint it is. So the brown one at the top left is a mechanical stop, the red one is a medical stop, the orange one is the SAG crew, and the blue one at the bottom is a rest stop. So checkpoint pins also have a number indicator that shows how many participants were last seen at that checkpoint. So when a participant with a beacon comes into range of one of the checkpoints, the number will indicate or update. And also when you tap on the pin, you'll be able to see a popover that tells you exactly which participant was last seen there. So these pin locations and the number indicators update near real time on all devices signed into the app. And staff can use this map view to get a sense of where participants are based on what checkpoints they were last seen at. So another thing you can see is the elevation graph, which is at the bottom of the map. It shows the elevation of the route from start to finish. So for this particular route, you can see it kind of starts at a higher elevation and gets lower. The main purpose of this is for staff members to know when a participant is about to approach a steep hill or incline. Another view we have is the participants view. This just shows a list of all the participants, their statuses, and how long ago they were last seen at which checkpoint. You can also add a participant, enter their name, email, and then optionally assign a beacon. If the beacon is assigned, then it will automatically start getting detected to be within range of certain checkpoints, and that will update the map view. And another feature we added is manual check-in and check-out for participants that don't have a beacon. As mentioned before, they're optionally assigned because event organizers may not have enough beacons to give to every single participant. This is also useful if someone's beacon is like broken or low on battery. So, for example, if I'm a checkpoint and I see a participant without a beacon come by me, I can use this view, hit check-in to indicate that they were seen at my checkpoint, and that will also update the map view. So the icons on the left show which participants were checked in via Bluetooth and which were done manually.
All right, so now we'll show you some of these features in action. So this is our demo. When you first open the app, as you can see, like before, we have two options. You can either select an event from the list or create an event. We're going to start with creating an event. So when you click that button, it brings you to the next page, which prompts you to sign in with Facebook. If you click on that, it navigates you out of the app to Safari in this case, and then you can open the app and confirm, authenticate, and then it brings you back into the app. After that, pulls up the create event page automatically. Here's where you'll populate information such as the event name and the PIN number, which is used by staff members on the day of the event to log into that particular race. You can also set things like a description. You can choose your event type, running, bicycle, or other. And you set a date. The date has to be in the future. And here is where you would put in the route number. So we already have created a route for this event, and so we're just going to type that in. When you click Save, it brings you into the app and shows you the map. I'm going to go back now and show you going through the event list. So if you select an event that's already been created from the event list, it brings you to the page where you can select which type of user you are. Currently, we only support staff and event admin. We're going to go with staff. When you go into the staff login page, the race ID is automatically populated based on which one you selected on the list. You then populate the PIN, which is given to you on the day of the race by the event organizer. You could optionally change your checkpoint name, and you can also set your checkpoint type and sign in. Once you sign in, it brings you to the map view, and as you can see when we zoom, it shows the route. In this case, the route goes around the loop of RIT. So we're going to go through and add some participants. So when you go here, add a participant, you can click on the bar to assign a beacon. These beacons are the ones that are in range of my device and detected. So I can select from that list and assign it to a particular participant. When you save, or when you add a participant, that information is saved to the participants list. It's also sent to our server so that the other checkpoints can get accurate information of participants in the race. Now if we go to add another participant and we go to assign them a beacon this time, the first beacon is still detected, but it said it's assigned, so we can't pick that one. It just allows us to pick the other ones. Again, we'll add their information and save it. This gets sent to the server, but is only gotten via polling every 5 seconds. Now we'll go to a different view. In this case, we are the orange checkpoint right there. That's us. We are a SAD crew mobile checkpoint, so we're going to be driving around. We have one person last seen at our checkpoint. As new checkpoints join in the race, they automatically pop up on the map. This is done using socket communication, as we discussed before. So now if we go to my checklist, you can see that all of the participants are currently unseen. That's because I recently reset my checklist, even though it says that one person was last seen at my checkpoint. If you look at the other checkpoint, we have 2 people that were last seen checked in there. If we go to the manual checklist, as we see them come to my checkpoint, I'm going to manually check them in. When we go back to the map view, we'll see that the number indicators have been updated, as well as lists to show at which checkpoint the participants were last seen. If we go back into the checklist, we can manually check them out, and that, however, will not update the indicators in the list because those show last seen at that checkpoint, not currently. That is a limitation of the hardware. So now we'll show a different scene. We've got our checklist with participants checked in via Bluetooth and manually. We're going to click reset, and that's going to wipe everything out. They're set to unseen. However, if a beacon is currently within range, they will automatically be checked right back in. As other participants come within range, they get automatically checked in via Bluetooth as well, which is pretty cool, in my opinion. So the last thing we'll show is just a little bit, all the checkpoints, or all the participants that are checked in my checkpoint, and we are driving with them. You can see that that's updated real time via socket communication. And that's done to ensure participant safety, of course. So that's our demo, and we will go back and...
Hey, awesome. So just some reflection items. So we found that field testing to make sure new features were working as intended was extremely important. Features like automatic check-in via Bluetooth was nearly impossible to validate just in the team rooms. There's certain use cases where we actually had to go out to the RIT loop and test it ourselves. Unfortunately, we kind of waited till the end of the semester to extensively field test this app, and we found many bugs and were able to squash them pretty quickly, but we could have definitely benefited from doing these field testing earlier in the semester, or once the features were actually released at the end of the sprint. But luckily, using Scrum helped us quickly reprioritize our stories so that critical bugs could be found and taken care of first. In the beginning of the semester, we pointed what ended up being rather large stories with lower values or lower, with higher values than they should have been. And that was fine for actually getting them done during the sprint, but it turns out that integrating those large stories together at the end, such as the Facebook login that goes into event creation that we saw earlier, integrating those kind of large stories often kind of went over our allotted time and went to the next sprint, which would kind of mess with our velocity. So we would have definitely benefited from making those stories smaller so we could not have those gigantic big bang integrations at the end of the sprint. We also got much better at tracking our bugs because we logged them right when we found them. That's something that changed from the first semester. We'd often just say, yeah, we'll log that later. But once we found the bug this semester, we would log it immediately. And as such, our bug tracking metrics were much better this semester. All right, so future goals. The website will be used as a social media platform for spectators. Right now, it is not used at all. It was used as an event creation tool for as the previous integration for the last team that worked on it. So there will be more user types, such as a participant user, who will be allowed to view other participants in the race and see how they're doing, and post to the social media platform that will be the website. So maybe they'll have like a comment like I'm really tired, or maybe post a picture so that spectators can view it on the app or on the website. We also account for races with laps. We currently do not account for that. Push notifications for event staff, and just in case there's an emergency or something everyone that needs to know. So that would be pushed to event staff and participants. And eventually, we will monetize the app, or the next team will monetize the app.
The next team. So that's our app. Are there any questions? Okay. I don't know who was first. We'll start with Brian.
So I've been to some of these races before, and they can have, you know, hundreds of participants that show up, and it seemed like that data entry was kind of slow. You know, you have to check in everyone every so often, like everyone as they come through. So that can be really time consuming. Is there any kind of plans for allowing, you know, either someone to check themselves in or having other people check, like having multiple people be able to check in users?
Yeah, so two things on that. So any staff member can check in users for the race. So if we have multiple checkpoints set up, we could have different lines for people to sign in. Another thing that is currently on the list of enhancements for hopefully next year's senior project team is to add kind of like a kiosk registration view so that the participants can just sign themselves in when they get to the race instead of having to have the staff members do it. Important.
Kind of a follow-up to that, but also one after that. So how would someone who is a part of like one of those teams discern between someone who has a beacon and who doesn't? So how would they know who to check in?
That's a good question. So currently, there is not that much of a way to discern between the two. However, there is an enhancement request from our sponsor to make on the participants list have a little Bluetooth icon for the participants who have a beacon assigned to them, so that the participants, or so that the staff members who, in the case of our sponsor, usually know most of the participants, they can keep an eye out for them and check the ones that don't have beacons in manually.
But on a larger scale, how would someone just looking at someone running by with a bib have any idea?
We actually have a something logged into our backlog where we discuss modifying the user database to support adding a little race number. You know those little paper rectangles you get. So like during the event registration, that would be an optional field that organizers or participants could enter themselves to kind of keep track of that. So from a distance, you could be like, I see 101 coming down here. Nope, they don't have a beacon, and then you can kind of check them off without having to actually know the racer themselves.
And we did have a story for putting just like a beacon icon for next to the icons for each participant. We just didn't get to implement that story.
Last question is that you mentioned that safety was kind of a huge component of this. Is there any kind of feature where if someone doesn't go check in after a certain amount of time that the race like staff are notified?
Yeah, so currently if a race or a participant is gone unseen for, I don't remember the exact time interval that we have set in there, but if they've not been checked in by anybody in that amount of time, their status will be set to unknown, and that will be updated on the participants list so that they can keep an eye.
Like, hey, this person could be like hurt somewhere.
Yeah, so that is for our future goals for the project, adding push notifications for the staff members.
We also have a chat that's currently implemented so that organizers can communicate between themselves. So if one person says, hey, I saw someone that went off the side of the cliff over here, they can know about that and they can be informed. So there is communication between staff members, so you can keep abreast of those sort of information.
Yeah.
I have a question just about your architecture. You guys had a lot of singletons.
Yes.
And some folks would consider that an anti-pattern because that operates on the assumption that there will only be one instance of that class ever. And like in your guys' case, like you had the HTTP thing, the singleton, like if you needed to make a request on another thread, you could run into some issues there. So I was just curious, and like getting rid of singletons is really hard because like it creates high confidence of the code that uses that singleton. Why did you guys choose to use so many singletons? Can you kind of go into that a little bit more?
Yeah, so like I said earlier, when we inherited the code, we kind of inherited a collection of view controllers, and all of the code was in the view controllers. So at first we knew that we needed to separate out all the functionality from the view controllers so that view controllers were just view controllers. At that time, that's when we decided to do a major refactor fall semester, and we started separating these out into services, which we decided would be best as singletons. As we continued moving through that, we started realizing that more and more of these services are needed, and they only should be used in one case or like for one specific purpose. So in addition to that, we wanted to use the singletons so that it would be easy to extend the app if you wanted to add another service that does a specific thing, like integrate with Fitbit or Under Armour technology. I know they have some sports things. That you could do that easily just by adding another service and integrating that into the app.
All right, let's thank the team.